Good morning, students. Welcome to the digital classroom with Holy Heart Schools. Today, we are going to continue with our chapter Rotation and Revolution. In today's video, we will be learning about the effects of Earth's revolution, the phenomenon of season, equinoxes, winter solstice, and summer solstice. While going through these topics, we will be learning some new words like number 1, revolution. Revolution is the movement of the earth around the sun. Number 2, orbit, the fixed path along which the earth revolves around the sun. Number 3, parallelism of the earth axis. The parallelism of the earth axis refers to the fact that the axis of the earth remain parallel to its previous position as the earth revolves around the sun. This means that the earth axis always points in the same direction. Number 4, solstice. Time when the sun rays fall directly either on the Tropic of Cancer or Tropic of Capricorn. Next we have summer solstice. The time when the sun shines vertically over Tropic of Cancer, that is on 21st of June. Winter solstice, the time when sun shines vertically over Tropic of Capricorn, that is on 22nd of December. And at last we have equinox, the time when sun rays fall directly over the equator and the days and nights are equal in both the hemispheres. Now students, please open up your chapter number 3, page number 28, topic phenomenon of seasons. But before we start today's topic, let's have a brief of this topic. As we have discussed in our earlier videos that the change of season occurs almost everywhere in the world, and this is due to the rotation of the earth, inclination of the axis, the parallelism of the axis. Parallelism of the axis means the axis always remain in the same position. But change in season is mostly affected by the revolution. Because of the revolution of the earth, we have in first phase summers, second phase rain, in third phase retreating monsoons, and in the fourth phase we have winter. Now how does all this happen? Suppose we take these four positions of the earth. In first position, the date is 21st of March. In the second position, the date is 21st of June. In the third position, the date is 23rd of September. And in the fourth position, the date is 22nd of December. When the earth is in second position, if we look carefully, the northern hemisphere is facing the sun. And when it is in the fourth position, the southern hemisphere is facing the sun. But when the earth is in first or third position, none of the poles are facing the sun. So the inclination of the earth axis does not have any impact on the sun rays that it receives. So on 21st of March and on 23rd of September, the vertical rays of the sun fall on the equator and the entire earth has equal day and equal nights. But as we move from first position to the second position, slowly the northern hemisphere tilts towards the sun. So in the northern hemisphere, the days become longer and the nights become shorter. And this gives rise to the summer condition. On 21st of June, the vertical rays of the sun falls directly on Tropic of Cancer. And this is referred to as summer solstice. Similarly, as we come to the fourth position, the date is 22nd of December. The southern hemisphere is facing the sun and the vertical rays of the sun falls on Tropic of Capricorn. And this is the time the northern hemisphere experiences the winter solstice. So now students, let's start with our reading of the day today. Phenomenon of seasons. We observe that there is a change of season almost everywhere in the world. This is due to the rotation of the earth. Rotation, as we have already learned, the movement of the earth on its own axis, the revolution of the earth, the movement of the earth around the sun. The inclination of the earth axis means the tilting of the earth axis, and we have already learned that the axis of the earth is inclined at an angle of 66.5 degree. And the last is the parallelism of the earth axis, which means the earth axis always remain in the same direction. From the 365 positions which the earth takes during the course of its revolution, course means the way or direction around the sun, 4 days can be suitably selected for understanding some of the important facts about the phenomenon of the seasons in one year. These are 21st of March, 21st of June, 23rd of September and 22nd of December. In two positions, that is on 21st March and 23rd September, the rays of the sun are directed overhead the equator. And as we have already discussed, when the sun rays are overhead the equator, there are equal days and equal nights in the entire earth. These positions of the earth are known as equinoxes. Equinox means equal day and equal night. Spring equinox on 21st of March and autumnal equinox on 23rd of September. In other two positions, that is on 21st June and 22nd December, the rays of the sun are directly overhead the Tropic of Cancer and Tropic of Capricorn respectively. Days are long and the nights are short in the respective hemisphere. These positions of the earth are known as solstices. Summer solstice on 21st June and winter solstice on 22nd December. This is in northern hemisphere. These are the longest and the shortest day of the year in the northern hemisphere. And this will be reversed in the southern hemisphere. On 21st of June, the southern hemisphere will have winter solstice and on 22nd of December, it will have summer solstice. Now let's study equinoxes and solstices in detail. Equinoxes are the moments when day and night are of equal length. Equinox happen when the sun is exactly above a planet's equator. This causes a dividing line between daytime and nighttime area to pass through the planet's north and south poles. This unique angle causes every area of the planet to experience approximately the same amount of daylight and darkness for the one day 2 times each year. The biannual phenomena are called the vernal equinox or the spring equinox and the autumnal equinox. In the Earth's northern hemisphere, the vernal equinox marks the beginning of the spring in March and the autumnal equinox indicates the beginning of fall in September. Along with the planet's two annual solstices, the two equinoxes mark the change in the season. So now let's read. The term equinox means equal days. In figure 3.9, the earth occupies position number 1 and 3 on 21st March and 23rd September respectively. These are the position of equinoxes. In the northern hemisphere, 21st March is a vernal or spring equinox and 23rd September is the autumnal equinox. The seasonal terms are reversed in the southern hemisphere. The following characteristics prevail on these two dates. The rays of the sun fall vertically on the equator. Although the earth's axis is tilted, it is neither away from the sun nor inclined towards the sun. The North Pole and the South Pole lie at an equal distance from the sun. This I have shown you with the help of a figure. The circle of illumination just touches both the poles and bisect all the parallel into two positions. Means divide them into two positions. As you have seen in the image, it is dividing the earth into two equal halves. The days and nights are of equal duration, that is of 12 hours throughout the world. The northern hemisphere experiences spring season on 21st of March and autumn season on 23rd of September. The situation is reversed in the southern hemisphere, as I have already told you. The dates of the equinoxes coincide with the time of sunrise at one pole and sunset at the other pole. It means when it is going to be sunrise in the north pole, it is going to be sunset in the south pole for the next 6 months. Next we have solstice. Solstices are the planet's longest and the shortest days of the year. The longest day often marks the beginning of summers and is called summer solstice. The shortest day often marks the beginning of winters and is called winter solstice. In the northern hemisphere, the summer solstice happens on 21st of June when North Pole is tilted most directly towards the sun. This tilt means the summer solstice has the most hours of sunlight and is the brightest day of the year. On this day, the sun shines vertically over the Tropic of Cancer and the northern hemisphere receives the maximum amount of heat. But on the contrary, the southern hemisphere receives the minimum amount of heat and experiences winter season. So now let's come back to our reading. Summer solstice. On 21st of June, the sun shines vertically over the Tropic of Cancer. On this day, the North Pole is inclined. Inclined means tilted towards the sun, while the South Pole is turned away from it. Following characteristics prevail due to this inclination. The northern hemisphere receives the maximum amount of heat and experiences summer season. The southern hemisphere receives minimum amount of heat and thus experiences winter season. This I have already explained with the help of an image. The circle of illumination. Illumination means the line that divides the day and night touches the Arctic Circle on the far side of the Earth and Antarctic Circle on the near side of the Earth. Thus, the Arctic Circle falls within an illuminated part while the Antarctic Circle lies in the darkness. We can experience the longest day and the shortest night in the northern hemisphere. The length of the day increases with the increasing latitude towards the North Pole. In this time, the region between Arctic Circle and North Pole experience 24 hours of daylight. In the southern hemisphere, the nights are longer than the days. The length of the day decreases with the increasing latitude towards the South Pole. And at this time, the South Pole remains under complete darkness for 6 months. The region of the Arctic Circle to North Pole experiences 24 hours of daylight, while the region from Antarctic Circle to the South Pole has 24 hours of darkness. The equator experiences 12 hours of day and 12 hours of night. Next, we are starting up with the winter solstice. In the northern hemisphere, winter solstice happens on 22nd of December when the North Pole is tilted furthest away from the sun. Because of this, the winter solstice has the fewest hours of sunlight and is the darkest day of the year. On this day, the sun shines vertically over the Tropic of Capricorn and the northern hemisphere receives the minimum amount of heat and experiences winter season. So now let's start with our reading. Winter solstice. On 22nd December, the sun shines vertically over the Tropic of Capricorn as you have seen in the image. On this day, the South Pole is inclined. Inclined means tilted towards the sun, while the North Pole is turned away from it. The following characteristics prevails due to this inclination. The southern hemisphere receives the maximum amount of heat and thus experiences the summer season, because at this time the sun rays fall vertically over Tropic of Capricorn. The northern hemisphere receives the minimum amount of heat and thus experiences the winter season, and this is due to the inclination of the Earth axis. At this time, the North Pole is farthest from the sun. The circle of illumination touches the far side of the Antarctic Circle and near side of the Arctic Circle on the Earth. Thus, the Antarctic Circle falls within the illuminated, means light up part, and Arctic Circle lies in the darkness. We can experience the longest day and the shortest night in the southern hemisphere, and the length of the day increases with the increasing latitude towards the South Pole. At this time, the South Pole remains in daylight for complete 6 months. In the northern hemisphere, the nights are longer than the days. The length of the day decreases with the increasing latitude towards the North Pole. The region from Antarctic Circle to the South Pole experience 24 hours of daylight, while the regions from Arctic Circle to the North Pole experience 24 hours of darkness. The equator experience 12 hours of day and 12 hours of night because the vertical rays of the sun falls directly over the equator throughout the year. So students, with this we are ending up with the chapter. Please revise the complete chapter and do all the question answers and exercises. Thank you.